Hello everybody, welcome to the Learning Management System. This is Jabin Banu M. Nada, lecturer in Electrical and Electronics Engineering, Government Polytechnic, Belagavi. Dear students, today we are discussing on the types of the filters and the working of those filters. Before that, let's have a quick recap on what we have discussed in our previous class. In our previous class, we have discussed about the filters. Filters we have discussed. In the filters, we have discussed about the definition of a filter. What is a filter circuit? A filter is an electronic device or circuit which removes the unwanted AC components. Which removes the unwanted AC components so as to give us a smooth DC for us. That was the definition of a filter circuit. If you look at the filter circuit, this is a filter circuit, and as per the definition, its work is to take the input as a rectified output and give us a smoothing DC output. Okay, smoothing DC output. This is a DC. This is also a DC, but this it is consisting of ripples. We have to remove the unwanted ripples or the AC components. Also, we have discussed in our previous class what are the elements or materials or components required for the construction of the filter. Okay, so we studied that the inductor L and the capacitance C are the basic elements of a filter. So, how the inductor helps for us for the basic filtering action. Because of its property, the inductor allows the DC and blocks the AC. This is the concept, dear students. You have to remember this one for the today's session. Then only you will understand the different topics or different types of the filter. So we studied the behavioral performance of the capacitance, and according to its behavior, it allows the AC and blocks DC. It allows the AC and blocks the DC. So these were the basic elements of a filter. With the help of this, I can have a L filter or called as a series inductor filter, C filter called as a shunt capacitor filter. Then I use a combination of LC filter called as choke input filter or inverted L filter. Then capacitors input filter I will take called as pi filter. So like this, depending on the combination of the filter components, we can design the different types of the filter. Our main intention is to get the smooth DC output. So because of this, we are using the different combination of the elements, passive elements they are called. Okay, then also we discussed why we are going for the filter, what was the necessity of the filter. The main necessity was because we are using an electronic device. The electronic devices are sensitive to noise. Therefore, the noise component which resembles just like the ripples have to be removed. The electronic circuit behavior is abnormal. Therefore, we have to compulsorily use the filter circuit. The second is we want a smooth DC at the output. Okay, because the kind of a DC we are getting, we are connecting to a load. And once we connect to a load, the load will be sensitive to the changes present at the input, which should not at all happen for us. We want a no variation or a constant DC output. Hence, for this sake only, we require the filters. We require the filters. The main theme or the concept behind the filter for the rectifier is basically the filtering action, removing the unwanted components. Okay, because the output of a rectifier is a DC and the majority of the electronic devices are based on the DC voltages. Hence, for the constant DC voltages, compulsorily we require the filters. Also, we studied some MCQs where in the mobile chargers we were using the filter circuits. There are certain applications that you compulsorily require the filter circuits. So dear students, let's quickly go for the today's class. Today's class we are discussing on the types of filter. In the types of filter, we are studying series inductor filter, shunt capacitor filter, choke input filter, and pi filter. Okay, in the series inductor filter, okay, if we look at the diagram of a series inductor filter, so see, we have what here? We have the output of a rectifier, a bridge rectifier, or a center tap rectifier. It is given to a circuit. The circuit is having what? The circuit is having a inductor in series between the rectifier and the load. ಲೋಡ್ ಮತ್ತೆ ಓಕೆ ಲೋಡ್ ಮತ್ತು ರೆಕ್ಟಿಫೈರ್ ನಡುವೆ we are connecting an inductor in series, therefore it is called as series inductor filter. Okay, and the type of the output what we are getting is shown to us. Okay, yes, so what is the work of an inductor? We have already studied in case of an inductor that inductor allows DC blocks AC. Inductor allows DC blocks AC. Okay. So if we look at the working of the in series filter, so I will connect the inductor here. Okay. To this, I will connect the output of a bridge rectifier. ಬ್ರಿಡ್ಜ್ ರೆಕ್ಟಿಫೈರ್ ಔಟ್ಪುಟ್ ಅನ್ನ ನಾನು ಇನ್ಪುಟ್ ಆಗಿ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಯಾತಕ್ಕೆ? ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್. ವಿಚ್ ಟೈಪ್ ಆಫ್ ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್? ಸೀರೀಸ್ ಇಂಡಕ್ಟರ್ ಫಿಲ್ಟರ್. Series inductor filter I am giving for us. So I will get the output of the filter as V0. So this approximately is the output of the filter. See, which looks that is which looks like approximately constant DC is present. Ripples are present, but a very small amount of ripples will be present. Okay, yes. But what is the working of the series inductor filter? So we all know that what is a rectifier? It is bidirectional voltage or current converted to the unidirectional voltage or current, which may have the unwanted AC component as the ripples. Therefore, I can write the rectifier as it consists of the AC components and the DC components. If this is applied to the inductor allows the DC and it blocks the AC. Therefore, AC component cannot reach at the output. By mistake or somehow by the concept of an AC which is forced to flow, some of the component may try to reach, but the percentage of the ripple present at the output here is very less. Okay, again they are giving certain definition of the ripple factor. Okay, let's quickly go to the slide. See, it consists of an inductor L. What is the inductor L? It is connected in series between the rectifier output and the load resistance. So just a brief discussion on what we have just learned just 2 minutes before. It has AC plus DC components. Inductors opposes AC and allows the DC. Therefore, only the DC component reaches to the load. So the ripple factor is given by the load resistance divided by 3 root 2 omega L. The ripple factor depends on the load resistance connected and the inductance connected in the circuit. If I want a high or less amount of ripple, then I have to wisely choose the value of L and the value of the RL. Okay. So let's go on for the next filter. The next filter is the shunt capacitor filter. Shunt capacitor filter. So as the name suggests, shunt means parallel. So parallel we are using the filter element. The filter element here is capacitor. So look at the circuit diagram. So we have a input to the filter C. Okay, and here the load resistance is connected, the output is given to the load resistance. Okay, the input to the filter circuit is coming from a rectifier, maybe a center tap rectifier ಇಂದ ಬರಬಹುದು ಅಥವಾ bridge rectifier ಇಂದ ಬರಬಹುದು. So what does the filter circuit consist of? It consists of a capacitors which is connected in parallel to the load resistance as well as in parallel to the rectified output. Anyhow, we can tell if load resistance ಗೆ parallel connect ಆಗಿದೆ ಅಂತಾನೂ ಹೇಳಬಹುದು, input of the rectifier ಗೆ parallel connect ಆಗಿದೆ ಅಂತಾನೂ ಹೇಳಬಹುದು. Okay, so this is the shunt capacitor filter. So what is the basic filtering action? So if you look at the output of a bridge rectifier, then we have the bridge rectifier output in this fashion. Okay, this is the bridge rectifier output. Okay, yes, and here I will draw what is the output of a filter capacitor, shunt filter output ಹಾಕ್ತೇನೆ. If we look at the output which is the input to the filter, ಇದು ಯಾವುದು filter ಗೆ ಎಲ್ಲಿಂದ ಇನ್ಪುಟ್ ಬಂದೈತಿ, output of the rectifier ಇಂದ ಇನ್ಪುಟ್ ಬಂದೈತಿ. So since we have a capacitance, the basic working principle of a capacitance is it allows AC blocks DC. Okay, this is the basic principle. Also the capacitor's most basic principle is it starts charging. It starts charging. Okay, see here we want DC ಬೇಕು ನಮಗೆ. Okay, yes, what does it does? All the AC will try to pass through this. Okay, all the AC, no, it tries to pass through this. None of the AC is present here. We don't know whether AC is coming here or AC is not coming here, because the capacitor acts as short to the AC supply. Okay, AC ಗೆ ಅದು lowest resistance offer ಮಾಡ್ತದೆ. Okay, for that sake what it does, it easily allows the AC. So what is the work of the C then? Its work is the charging and the discharging action. So as the AC supply moves from 0 to 90 degrees, this is 180 degrees, this is 90 degrees. Okay, so the capacitor starts charging. See, look at the waveform what I am showing. It starts charging, goes on charging till the filter or the capacitor voltage reaches the maximum positive voltage. Okay, ಅದು ಇನ್ಪುಟ್ ಗೆ ಫಾಲೋ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತದೆ. ವೈ? ಬಿಕಾಸ್ ಅದು ಚಾರ್ಜ್ ಆಗ್ತಾ ಇರ್ತದೆ. ಚಾರ್ಜ್ ಆದಂಗೆಲ್ಲ ಅದು ಇನ್ಪುಟ್ ಗೆ ಫಾಲೋ ಮಾಡ್ತದೆ. ಸೊ ಎಲ್ಲಿ ಮಟ್ಟ ಫಾಲೋ ಮಾಡ್ತದೆ? ಅಂಟಿಲ್ ದ ಇನ್ಪುಟ್ ವಿಎಂ ಗೆ ಬಂದ್ರೆ ಕೆಪಾಸಿಟರ್ನು ವಿಎಂ ಮಟ್ಟ ಚಾರ್ಜ್ ಆಗ್ತದೆ. ಇಟ್ ಚಾರ್ಜಸ್ ಟಿಲ್ ದಿ ವಿಎಂ. ಓಕೆ, ಆಫ್ಟರ್ ದಟ್ ದ ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಡಿಕ್ರೀಸಸ್. The capacitor's work is after charging it will not decrease, it will slowly try to discharge. Okay, first ಏನಾಗ್ತದೆ, ಇನ್ಪುಟ್ ಗೆ ಫಾಲೋ ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಅದು ಚಾರ್ಜ್ ಆಗ್ತದೆ. It is charging. Okay, it starts charging. Afterwards, okay, it will not immediately become slow or less because input is decreasing. Input fast ಆಗಿ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ. ಅದರ ಅರ್ಥ ಕೆಪಾಸಿಟನ್ಸ್ ಫಾಸ್ಟ್ ಆಗಿ ಕಡಿಮೆ ಆಗಲ್ಲ, because the charging and discharging is given by the time constant of the capacitance, R into C. ಇಲ್ಲಿ ಆರ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಸರ್ಕ್ಯೂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಥವಾ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಅದು ಟೈಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅದರ ಟೈಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಎಷ್ಟಿದೆ ಅದರ ಪ್ರಕಾರ ಅದು ಡಿಸ್ಚಾರ್ಜ್ ಆಗ್ತದೆ. ಸೊ ಇಟ್ ಮೇ ಡಿಸ್ಚಾರ್ಜ್ ವೆರಿ ಫಾಸ್ಟ್, ಈ ತರನು ಆಗಬಹುದು, ವೆರಿ ಸ್ಲೋ, ಈ ತರನು ಆಗಬಹುದು. ಸಿ, it may discharge the dotted line path also, or it may discharge the straight line path also. What I have shown, ಇವು ಎರಡು ಯಾವ್ದಾರ ಒಂದ್ ಆಗ್ತದೆ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಟೈಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ ದ ಕೆಪಾಸಿಟನ್ಸ್. ಟೈಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಜಾಸ್ತಿ ಇದ್ರೆ ಜಾಸ್ತಿ ಟೈಮ್ ತಗೊಂತದೆ, ಟೈಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕಡಿಮೆ ಇದ್ರೆ ಕಡಿಮೆ ಟೈಮ್ ತಗೊಂತದೆ. ಓಕೆ, ಸೊ ಇಫ್ ಇಟ್ ಈಸ್ ಟೇಕಿಂಗ್ ದಿಸ್ ಪಾತ್, ಓಕೆ, ಸ್ಲೋಲಿ ಡಿಸ್ಚಾರ್ಜ್ ಆಗ್ತಾ ಆಗ್ತಾ ಬರ್ತಾ ಇರುತ್ತೆ. ಬಟ್ ದ ಇನ್ಪುಟ್ ಆಲ್ರೆಡಿ 180 ಆಗಿ ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಪಾಸಿಟಿವ್ ಗೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಸಿ, ಇನ್ಪುಟ್ ಇಸ್ ಆನ್ ದ ವೇ, ಇನ್ಪುಟ್ 0 ಆಗ್ಲಿಕ್ಕೆ ಬಂತು, ಬಟ್ ಕೆಪಾಸಿಟರ್ ಸ್ಲೋಲಿ ಡಿಸ್ಚಾರ್ಜ್ ಆಯಿತು. ಇನ್ಪುಟ್ 0 ಆದ್ರೂ ಕೆಪಾಸಿಟರ್ ಇನ್ನೂ ಡಿಸ್ಚಾರ್ಜ್ ಆಗ್ತಾ ಇದೆ. Okay, then the next input will start. Next input start ಆಗುತ್ತೆ. So capacitor ಏನು ಮಾಡಬೇಕು ಮತ್ತು ಈ ಪಾಯಿಂಟ್ ಇಂದ again it will charge this much, it will charge, again it will discharge, again it will charge, again it will discharge. So process goes on repeating. So you can have a look here. Capacitor charges, slowly discharges, again charges, slowly discharges, again charges, slowly discharges. So this is telling us that it has almost removed the AC components, giving a very small amount of AC here. So illinda hididu illi mata, see, the AC component is very less here. So AC component is very less here. Okay, by one concept, the concept of the capacitors ಇಟ್ಕೊಂಡು ಅದರ ಕಾನ್ಸೆಪ್ಟ್ ಸ್ಟಡಿ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಅದರ ಪ್ರಕಾರ ನಾವು AC component ಯಾವ ತರ ತೆಗಿಬೇಕು. ಸೊ ಶಂಟ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಟೈಪ್. ನಾವು ಈ ಟೈಪ್ ಮಾಡಿದ್ರು AC component ತೆಗಿಬಹುದು. ಸೀರೀಸ್ ಇಂಡಕ್ಟರ್ ಹಾಕಿದ್ರು ನಾವು DC component ಗೆ ಅಲೋ ಮಾಡಬಹುದು. ಬಟ್ ಅದರಲ್ಲಿ ಕೆಲವೊಂದು AC component ಮಿಸ್ಟೇಕ್ ಆಗಿ ಬರುತ್ತೆ. ಬರೋದಿಲ್ಲ ಅಂತಿಲ್ಲ, ಬರುತ್ತೆ. You will not have a perfect DC output. You will be having a 95 to 96% of the DC output in case of the filters. Okay. So let us see here. So whatever just talked for you, the same thing is given here. The rectifier has AC plus DC components. In the positive half cycle of the rectifier output, the capacitor charges till it reaches the positive peak. At the same time, it will supply the current to the load. Okay. After the positive peak, the capacitor discharges. Till where it will discharge? Till it will reach the next positive peak. And the process repeats. Again, we have a equation for ripple factor here, which is given by 1 upon 4 root 3 FCRL. If you look here, the ripple factor is again depending on the value of the shunt capacitance and the value of the load resistance. Okay, so depending on the value of the C, we can fix how much amount of ripple we want at the output. ಕಡಿಮೆ ಬೇಕು ಅಥವಾ ಜಾಸ್ತಿ ಬೇಕು. And it is inversely proportional to the capacitance. So we have to carefully or wisely decide the value of a capacitance. So the next type of filter is a LC filter or inverted L filter. L ಉಲ್ಟಾ ಇದೆಯಲ್ಲ, ಅದಕ್ಕೆ ಇನ್ವರ್ಟೆಡ್ L filter. ಇಂಡಕ್ಟರ್ ಅಂದ್ರೆ and the name for inductor is choke. Choke ಅನ್ನು ನಾವು ಇನ್ಪುಟ್ ಕೊಡ್ತಾ ಇದೀವಿ. Therefore, it is also called as choke input filter. Okay, what does the LC filter consists of? It consists of a choke ಅಂದ್ರೆ inductor L, which is connected in series with the rectified output and the filter capacitor. Capacitance point ಮತ್ತು rectifier point ನಡುವೆ series ಅಲ್ಲಿ ಇದೆ. Okay, the capacitance is connected in parallel to the load resistance or in parallel to the input. Okay, the connected circuit resembles an inverted L, therefore it is called as an inverted L filter, or the input is an inductor or choke, therefore it is also called as a choke filter. So the basic principle of this is, the basic working principle of this is, we know what is the working of L. What is the working of L? Inductor allows DC, blocks AC. Capacitors opposite, allows AC, blocks DC. ಈ ತರನು ನಾವು ಹೇಳಬಹುದು. Okay, so this I told you in the previous class also, and the starting of this class also. You have to remember this one, then only you will understand. Okay, so if we give the rectified output, which is having the AC plus the DC components as the input to the filter, the input to the filter is the output of a rectifier. And if you look at the output voltage of a filter, so we have the inductance which allows only the DC components. What does it does? It blocks the AC here only. AC ಅನ್ನ ಇಲ್ಲೇನೆ ಬ್ಲಾಕ್ ಮಾಡ್ಬಿಡ್ತೈತಿ, ಬರೀ DC component ಅನ್ನ ಒಳಗಡೆ ಬಿಡ್ತೈತಿ. So the DC component will reach the load. Okay, And also we in the series inductor filter we told that sometimes some very small amount of AC component has managed to pass the inductor and reached. ಆ ತರ ಆದ್ರೂ this small amount of AC component is passed through the capacitance. Thereby only pure DC or almost 99% DC is reaching the load. So this is the working of a choke input filter. You can look at the waveform that see this is the amount of the ripple. The ripple goes on reducing as I change my circuit. In series inductor filter, I had I had a bit I had a DC which is consisting of a ripple factor. The ripple factor was little bit more. In case of the shunt capacitance filter also the ripple factor was more. We had a capacitance connected in parallel in case of a shunt filter, and in the choke input filter we included the combination of both, but we also have a very small amount of ripple factor, maybe it's a 10 to 20% of ripples we have. Okay, yes. So just you can look at the ripple factor equation. So that is all that I have already discussed then. See, if you look at the ripple factor equation, the ripple factor is independent of the value of L line C. Hence, I can tell that this is a versatile and robust type of the filter circuit. ಯಾಕಂದ್ರೆ ಅದು ಡಿಪೆಂಡೇ ಆಗೋದಿಲ್ಲ ಎಲ್ ಮತ್ತು ಸಿ ವ್ಯಾಲ್ಯೂ. Of course we can now design ಮಾಡಬೇಕು. ಡಿಪೆಂಡ್ ಆಗಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಎನಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಲ್ ಅಂಡ್ ಎನಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸಿ ಐ ಕೆನಾಟ್ ಯೂಸ್. ಓಕೆ, ಐ ಹ್ಯಾವ್ ಟು ಡಿಸೈನ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಲ್ ಅಂಡ್ ಸಿ. ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂನ ಡಿಸೈನ್ ಮಾಡಬೇಕು, ಬಟ್ ಆ ವ್ಯಾಲ್ಯೂ ಪದೇ ಚೇಂಜ್ ಆದ್ರೆ ನಮ್ಮ ರಿಪಲ್ ಫ್ಯಾಕ್ಟರ್ ಚೇಂಜ್ ಆಗಲ್ಲ. Okay, it is not depending on the value of the L and C. Of course it depends on the value of load, that is immaterial, but it is not depending on the value of the L and C. Okay, so the next type of filter is the pi filter. See, pi filter, pi symbol ತರ ಕಾಣ್ತಾ ಇದೆ, ಅದಕ್ಕೆ pi filter ಅಂತ ಇದೀವಿ. So again the input to this filter, the input to this filter is the output of a rectifier, and the output of a filter, okay, the output of the filter is a constant output. Okay, so again we'll recall what is L, inductance, LOs DC, blocks AC. See, these are all we have studied. Okay, okay, capacitance, LOs AC. ಇದೆಲ್ಲ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. Starting of the class only I have told blocks DC. So the same concept. So the AC plus DC components are present in the rectified output. Okay, so of the AC plus DC components, the 90 or 95%, the 95% of the AC components passes through the capacitance C1. So it passes through the capacitance C1, thereby leaving here very say 5% AC which will manage to flow, or 2% or 1% plus the DC will be left. Where? At this point. Okay, other all AC has passed to the capacitance. Okay, so what is the inductor? It all allows the DC. Therefore, here I will get DC output. Plus again in this 5% of EC ಎಷ್ಟಾದರೂ ಪಾಸ್ ಆಗಿ 5% ಪಾಸ್ ಆಗಿ ಬಂದ್ಬಿಟ್ರೆ ಆ 5% ಆ remaining part of the AC passes to this capacitance. Hence what? Hence we'll get, see here, as compared to the previous waveform, this waveform is a bit smooth. Smooth ಇದೆ. So here the ripple factor is very less. Almost because of the pi configuration, we have reduced the content of the ripple. If such stages are used, if I use like this, one stage use ಮಾಡ್ತೀನಿ, this is one stage of pi filter, this is second stage of pi filter, this is third stage of pi filter. Okay, like this if I use the multiple stages, okay, then what happens is the smoothing of the output is obtained. I may get a smooth output of this type. Okay, see, so why we required filter we discussed in the previous class, and depending on circuit configurations of the passive elements L and C, we have arrived at almost smooth output, which is 99% DC and approximately 0.01 or 0.001% of ripple will be present, which is very, very negligible and can be neglected for the electronic circuits. So again, see, you can look here, the ripple factor depends on the values of C and L. So carefully or wisely we have to design the circuit. But this ripple factor value is very, very less in case of the pi filter as compared to the other filters. Hence, though the LC filter is a robust and versatile filter, many of the filter circuit will employ the pi filters because of its least ripple factor. So we are talking of the ripples, okay, ripple factors we talked. Then we talked about the different configurations. L series inductor kaltvi, parallel shunt capacitor or parallel capacitor kaltvi, choke input athwa LC kaltvi. Pi filter is the widely used filter. Okay, but the capacitance allows the AC, inductance allows the DC. If at all any AC has left, that AC is allowing here. What is the meaning of this? The meaning of at the output we are bothered, okay? At the output, the meaning of this is capacitance charge ಅಲ್ಲಿ ಇರ್ತದೆ. It will be in a charge position. Okay, and load ಗೆ ಅದು connect ಆಗ್ತದೆ. Load may be any mobile charger again for example. Okay, yes. But if at all the circuit is open and I want to see whether the circuit is working or no, it is not charging, sorry, it is not giving plus 5 volts at the output for me. DC correct plus 5 ಬರ್ತಾ ಇಲ್ಲ ಇಲ್ಲಿ. Okay, 3.5 volt or 2 volt. So the person who is troubleshooting the circuit, what he does or she does, he or she will try to investigate circuit. Capacitor fault irbodu ಅಥವಾ inductor fault irbodu. So because of the charge, okay, because of the charge and the transients, the person who is troubleshooting may receive a shock because of the inductor also, because it is a choking circuit, and because of the capacitor also. Okay, for that sake, we have to provide a path for the discharge of the capacitance. Therefore, we are providing a small resistance in parallel to the capacitor so that whenever the filter is off or whenever the application is off, the capacitor will discharge, or whenever the person has to troubleshoot, he will or she will not receive the shock because of the discharging of the capacitor charges as well as a choking effect of the inductor. This resistance is called as a bleeder resistance. For the protection of the human beings as well as for the protection of the transients of the circuit, filter circuit, we are employing the bleeder resistance. The meaning of power supply here is not the input AC power supply, it is the rectified output, because the rectified output acts as an input to the filter. Okay. So dear students, we studied about the different types of the filters, and in all the four cases of the filters, we studied that how one filter is more advantageous over the another filter. Okay. So these are the references what I have referred to prepare today's content. You can also have a look on the website www.tutorialspoint.com. It is easy for you all. You can also have a look there and understand the topic which you have not understood from here. So let's have a quiz time. A circuit which removes the AC component in the rectified output and allows the DC component to reach to the load. See, read the question carefully. A circuit which removes the AC component in the rectified output and allows the DC component to reach to the load. ಯಾವ circuit AC components ತೆಗಿತೈತಿ, DC ಗೆ allow ಮಾಡ್ತೈತಿ? So I think you guess the answer. The answer is option A, filter circuit. So from previous class also we are continuously defining the definition of a filter, that a filter circuit is a circuit which removes the AC components, thereby giving an almost constant DC output to the load. So the series inductor filter, see look, series inductor filter ಯಾವ ತರ construct ಆಗಿದೆ. It is constructed by connecting the inductor through connect ಮಾಡ್ತಾರ ಎದ್ರ ಜೊತೆ series ಜೊತೆ ಮಾಡ್ತಾರ between which two components, between capacitor and load connect ಮಾಡ್ತಾರೋ ಅಥವಾ between rectifier and load connect ಮಾಡ್ತಾರೋ ಅಥವಾ ಎರಡು ಮಾಡ್ತಾರೋ. That is the meaning of this question. Okay, a series inductor filter can be constructed by usually if we have a filter, at the input we have the rectifier output, at the output we have the load resistance, and here I am connecting a series. So the answer is option B. Sorry, the answer is option B. Wrongly mentioned here. The answer is option B. So these are the references what I have chosen. Sorry, these are the resource persons who have made this content to be successful. Thank you one and all.